Okay, I'm going to go through a little tutorial on how to find the standard deviation from a set of grouped data, and I'm going to go through how you would do it without using the functions on a calculator. I've already done a video on how to find the standard deviation using the calculator functions on the class whiz, but I'm going to go through it step by step how you would do it without those functions if they asked you to do that on an exam. So the first thing to note with this particular example that I've picked out is that the information is not given in an appropriate way. These numbers have been rounded to the nearest millimetre, and so there's gaps in our data at the moment. So this should actually say 124.5 up to, but not including, 139.5. The next one should be 139.5 being included up to 154.5, and that way there's no gaps. So if a worm had a length of 139.27, we'd know that it would be in this category, and that's really important for standard deviation and for finding the median as well, which I'm going to do in another video. So I'll just finish off putting the new boundaries in. And if they gave you data like this on a test and the data was continuous, we don't have to do this for discrete, but if the data is continuous, then this is the first thing we have to do. Hopefully they'd give it you in this form already and we wouldn't have to do this. $184.5. Okay, so once we've done that, we're now ready to find the mean and the standard deviation. You will always be asked for the mean and the standard deviation because you need the mean to find out the standard deviation. Now the formula for mean is, and I'm going to use X bar for that, or I should use W bar because I've used W here for my worms. So W bar is going to be the sum of F times W divided by the sum of F. So this is, I'm going to need a column for W, which is going to be in this case the midpoint of these values because they're grouped data, and I'm then going to use times these numbers together to get my FWs, and then I can use this formula to work out the mean. So I need my the midpoints of the intervals first of all. You can find that just by observation, so halfway between 125 and 139. If you're not sure how to do that just by observation, you can always find the midpoint of these two numbers or the average of those two numbers. So if I averaged out those two numbers by doing on my calculator 124.5 add 139.5 and divided that answer by 2, that would get me the midpoint, and for that one that's 132. If you can see that the answer is going to be 132, and notice the midpoint here is the same as the midpoint here because on this one we've just extended each end by a half, so the middle is still going to be the same. So I'm going to do that for all of these numbers. Again, if you want to do it on your calculator, add them up and divide by 2, that's absolutely fine. Or if you can spot the midpoint just by knowing what's halfway between the two numbers, that's absolutely fine as well. So for this one I know it's going to be 152, this one I know is going to be 177, 192, 207 and 222. So I've got my midpoints sorted, that's what this column shows. And then the next thing I need to do is find the sum of the frequencies times the length, the midpoints, the frequencies times the midpoints. So I'm going to make another column here. And I'm going to do 4 times 132. Four times 147. And it's really easy to make a mistake on these, so make sure you don't go too quickly. Check that your answers make sense as well. You don't want to be writing silly numbers down, because that's obviously not going to get you the correct answer. Okay, so now we need the sum of the frequency times the W's. The sum of the FW's is going to be the sum of these numbers here. So I'm now going to add up 528, 588, 304, 1239, 3840, 4968 and 2220. So that's 13687. We're then going to use this formula. So the sum of the FW's, which is this, divided by the sum of the frequencies. So we need to add the frequencies up. 4, 4, 2, 7, 20, 24 and 10. So that comes, I reckon, to 71. 71. So the mean is then going to be 13687 divided by 71. Which is 192.8 millimeters, or 193 to 3 significant figures. Okay, now to find the standard deviation, we are going to need to use this number later on. So I'm now going to store this number into the memory of my calculator. I'm going to store it into memory A. If you don't know how to store a number into the memory of your calculator, I've made a video on it on several different types of calculators. It's a really, really useful thing to be able to do. You'll see why in a minute, but for standard deviation, it's a really useful tool to have. Now, to go on and find the standard deviation now, we're going to need to use the formula for standard deviation, which is denoted by a sigma, a lowercase sigma, and is the sum of, in this case, the W's, the sum of FW squared divided by the sum of the F's minus the mean squared. So the square of the mean that we worked out earlier. That's why we need to store the full number on this. That would get variance. We then need to square root all of that. All of that gets square rooted to find the standard deviation. So we've got the W, which we can square. We've got the F, the sum of F was 71. We need this sum of FW squared. Now a really common mistake is for people to square this number. That is not correct. The square of that number would get us the sum of FW all squared. What we want is to work out each value of F times W squared, so 4 times 132 squared, so squaring the 132 and not the 4, working each of those out and then adding them up together. So I'm now going to work out an FW squared column, and the first number I'm going to do is 4 times 132 squared. Okay, so 4 times 132 squared, we're just squaring the 132, we're not squaring the whole thing, and that comes out at 69696. The next one I'm going to do is 4 times 147 squared. Which which is 86436. 2 times 152 squared is 46208. 7 times 177 squared is going to be really big. 7 times 177 squared is 219303. 20 times 192 squared is 737280. 24 times 207 squared is 1028,376, and 10 times 222 squared is 492840. Now I need to add together all of these numbers. So 69696, add 86436, add 46208, 219303, 737280, 1028,376, and 492840. So I get 2680,139. That is the sum of FW squared. So we can now use the formula that I wrote down here. So we're going to have, and we can type this all in on the calculator in one go, or you can do a bit at a time. 2680,139 divided by 71 minus the mean squared. So minus 192.8 squared, and all of that needs to get square rooted. Now, when I type this into my calculator, I'm not going to type 192.8 squared, I'm going to type in a squared, because I saved a as this number, the full real value of that number. And that's going to give me the most accurate answer I can get. So 2680,139 divided by 71 minus a squared, and then I'm going to square root that number. That number at the moment is 586.4. That's the variance. So sometimes they'll ask for variance, and if they do, that's the number we give. Most of the time they'll ask for standard deviation, and we need to square root that number, and that's coming out at 24.2. So standard deviation for this question is 24.2, and that's rounded to 3 significant figures.